Hey there, welcome to this week's video overview. The main goals for this week are to finish Chapter 3 material, which includes the word problems, including 3, 4, 5, or more variables, oftentimes called related rates. This is our last application of the chain rule in Chapter 3. And then for 3.10, the topic is local linearization, which basically boils down to using a tangent line to approximate a function, and that's locally in the local linearization part of that description. The big ideas are, the first semester calculus is called differential calculus because it's about derivatives. And derivatives, as we've seen, are rates. So first semester calculus is about rates. In real-world applications, there are oftentimes many different variables involved. The example on the screen here is a simple example of a splash, a pond, where a ripple of water is expanding. And so we have variables of area and radius and time. That's 3 variables. But we can have much more complicated examples in terms of profit. Your profit definitely can depend on the price that things are sold at. It could also depend on what kinds of costs you have, so what kind of fixed costs or overhead costs you have. It could depend on the quantity of things that are sold, the different taxes and things that the government's going to ask you to pay. And all of these things can change. So if you're looking to see how your profit's changing, that's related to how all these other variables are changing. The rates are related to each other, and thus we have the topic related rates. So that's the big idea there. In terms of local linearization, the big idea there is that on a microscopic level, things tend to look like straight lines. I have an example here of some curvy thing. This is a complicated sine wave type equation, and it's definitely curvy. But if I zoom in any place, it looks like a straight line. And that could be anywhere. I could zoom in any location and it looks like a straight line. For example, let me zoom in on the location where x is 3. And that's this location right here where y is about negative 2.515. And if I zoom in enough, you can see that that's basically a straight line. So on a microscopic level, all of these curvy things look like straight lines. Well, what kind of straight line are we going to use? What equation are we going to use? We're going to use the tangent line equation. So here's the tangent line equation, and you can see that right around 3, the tangent line equation is pretty much identical to the function. It's very difficult to see any difference. If you move away from 3, from our local point, you can see there's a difference between a value of the tangent line and a value of the function. So certainly it's local, but we can do this kind of local linearization anywhere we want. And we can do this very sophisticated and efficient and basically break this entire curvy thing down into a bunch of little straight lines. So local linearization is our first approach at looking at breaking complicated functions into a bunch of straight lines. And our first pass in Chapter 3, 3.10, is just to try to approximate values of functions using these local linearizations. So that's the big idea behind that. This deconstructing thing we're going to be doing a lot more, and in Calculus 2, I hope most of you take Calculus 2, it's used quite a bit. So it is a little bit of foreshadowing towards future applications and math courses as well. Okay, so some stumbling points. We have word problems. There are definitely going to be word problems here because of the related rates problems. And so for word problems, whichever ones we have, remember we have a problem-solving process. Make sure to read the problem carefully, identify the question, the variables, and the constants. Organize the information using a diagram, a table, etc. Write down what each variable is measuring, the values of the constants, and use the calculus d something notation to represent the rates. I always recommend putting all of that information in your diagram or in your table. So don't just have those ideas written somewhere on the side, but incorporate them in the way you've organized your information. The next step is to use your knowledge of geometry or precalculus to write an equation that relates the variables, that uses the variables that you're using for this problem. You're going to find the derivative using the chain rule. Make sure you know how to find the derivative using the chain rule, and you're finding the correct derivative because of what you're looking for. If you're looking how area changes in time, that means you need to find the change in area over the change in time, and that's the example I had originally over here. We're looking for the change in area over the change in time, so we differentiate this equation with area in it with respect to time to find dA dt. And then lastly, what we're going to do is we're going to substitute whatever values and constants we have into the derivative equation in order to answer our question, and then review our work and check that the answer is actually reasonable. So that's sort of the problem-solving process that you're going to be practicing for these rate problems. Knowing what formula to use can sometimes be tricky. Remember, the variables are the key. So, if you have a question about area, you need to be thinking about an area equation. Remember that you have a bunch of geometry and precalculus, so you can review the formulas you did in those classes, but that may be kind of a distant memory for some things. So just reach out to me or to Google or whatever reference you use, resources you use to get the formulas. For example, what's the surface area of a sphere? A lot of people don't remember that, but it's easy to ask or to look up if you don't quite remember formulas such as that. Okay, reminders. Remember to organize all your formulas and whatever calculus notation in your notes. Notation can be kind of tricky as well in this section because of the way they write local linearization. I promise you it's just a tangent line, even though it's going to look a little bit more complicated at first. And all of the, chain rule stuff, notation can be a little complicated. So make sure to organize all that to make your life just a lot easier. Please keep working ahead of those due dates, making sure you don't feel stress about doing things in the last minute. See me or the LMC Tutoring Center or Math Lab if you have any questions and want some expert assistance. Remember to contribute to the weekly discussions, and I hope you have a great and wonderful week, and I hope to talk to you sometime soon. Okay, good luck.